So, welcome to this first lecture on this physics, in which we will start with the units and dimension. And before I go into the actual physics lecture, I would like to give you some introduction of what this course is about and how you are going to proceed about it. So, in this lecture, we will have a series of lectures of physics, starting with this particular lecture, and then we will cover all the topics: kinematic mechanics, current electricity in part 2, and so on and so forth. We plan to give you one lecture for every week, and this will be typically 50 to 1 hour of durations. I will try to keep it less than 1 hour because it gets boring if you keep looking at for more than 1 hour. And our method of teaching will be to focus very little on the theory itself. We will tell you only maybe a couple of minutes on one particular theory. We will derive the formula and the little concept behind it. But what we are going to focus is, we are doing a lot of questions, because this course is for class 11th of the Indian colleges, and which is primarily focused on eventually giving an entrance examination of either NEET for the biological stream or the IIT main and advanced for the engineering streams. And both these exams focus more upon your problem solving capacities. So we will start with solving a huge lot of problem right on this board itself. And what you need to do is look at this lecture and then go back and do all the problems that as much as you can. So you don't need to go study as much of theory as you need to. What you need to do is, let's say you do a problem and you are stuck at some problem, and you go back to the book, refer that book or the video lectures here, and see if that helps you. Because over the period of time, you're going to forget about this, all the theory, and what you will be left with is what you have applied your mind in solving the problems. In terms of the books that we are going to follow, I can list out all the books here, but the book that I ask you to follow is H.C. Verma. It's a really very good book, and the reason I am referring to H.C. Verma is a perfect balance of the theory and a lot of problems, solved problems as well as unsolved problems. You can also refer to the NCERT books, but only reason I'm not referring you to NCERT as your main textbook, that it has a lot of theory and they are very fantastic, they are very nice. But if you read the book and you refer it and you try to recall it after like 6 months or a year, you probably would have forgotten most of the stuff. What you'll be left with are the problems that you'll be solving in either H.C. Verma or in NCERT. And for this reason, I would rather prefer another book called D.C. Pandey, and this is very good because it talks very little of the theory and a huge lot of problems, and that's what is going to help you in cracking the engineering or medical entrance exam. I can also refer to another two books, Holiday and Resnick, and also Iridov Physics, but probably looking at the current IIT standards, there are simpler problems coming up relatively, but if you have time, you can solve the problems of these two books. But at the end of the day, you essentially don't need any book. You will also have links at the end of this video that you can follow, that will have a problem sheet, and if you can solve these problem sheets, you should be good to go in any engineering or any other entrance examination. Before going to further, one thing I wanted to do is that we also have a link. We'll have a link at the end of the video description, where we will have where you can log in, and you will be taken to one particular chapter, and once you log in, it will show you a default score of something like 1200, and it will present you the problems based upon your capability. So if you are not able to solve the problem, it will reduce your rank from, let's say, starting from 1200, it will go down to something 1180, 1170 or something like that. If you solve a tougher problem, it will increase your rank to something like 1250 to 300. You solve more tough problems, you keep increasing your rank for that particular chapter all the way to something like 2500 or 3000, something like a ELO ranking in a chess. What it will do, it will present you a problem which will be of your level, and by keep trying the tougher and tougher problems, you will eventually go to a rank of 2500. If you reach a rank of 2500 or so, you are pretty much close to cracking the engineering or NEET entrance exams. That's one of my motive of covering the topics in this one. So let's start with the actual course, where I will be starting with the units and dimension. Basically, we are covering more of the dimensional analysis, which is the very first chapter of this. So units, you have already studied about it. We have covered these first three things, so I'm going to make space for my lecture. The units we have already covered in class 9th and 10th. If you have not gone through, so basically there are two types of basic unit. One is MKS unit and SI unit. MKS unit, we measure the length in meter and weight in kilogram and time in second. SI unit is the same as MKS unit, but it extends it so that we also are able to measure the current in electricity, we can measure the current, we can measure the temperature, and we can also measure a couple of other things. The total of 7 different things we can measure, 3 plus 2, and a couple of other things like mole and angles and things like that. And there is another unit that we will be referred to in the problems. It's called CGS unit. So basically, the CGS unit does not like the meter here. Instead of meter, it likes to measure everything in centimeter, and it does not like to measure everything in kilograms. It likes the grams. So if you ask a question, all you need to remember is we need to measure everything in centimeter and grams instead of meter and kilometers. Units are very important because if you already have given some exams in class 9th and 10th, you notice that if you don't write the units, the teachers like to deduct some marks from it. And the reason is very simple. Let's say I ask you, when are you going to come back? And you say, after maybe like 3. Then that does not mean anything, because 3 what? 3 minutes, 3 hours, 3 days, or whatever. So the person who is asking you a question is not very happy if you don't mention the units, and that's why the teachers, the physics teacher who's checking your copy, don't like it if you don't mention those units. So that brings us, now the problem with the units is it's very dependent upon whatever things, but there is another thing which we call dimension that is not dependent upon what the units you are measuring, and that brings us to the dimensions. So let's start with the examples. We have now come into the mode where we will start looking at the examples and leaving the theories behind. Let's say we have a velocity, and then with velocity we know is displacement divided by time. Now in the units we try to find out the units of displacement and try to find out the unit of time. But in the dimensions we are not worried about the units, but we know that displacement is a measurement of the length. We denote it by L, and the time we know that is represented by T, no matter which unit we measure in. So basically there are 3 fundamental units upon which any quantity can be represented. One is mass, one is L and T. There are a couple of others that we will worry about later. So for example, the velocity we can represent in terms of L and T, and we write it as L and T, and we enclose it into the bracket, and T to the power -1. So the LT powers and T to the powers of this L and T are basically the dimension of velocity, and we write it as dimension of velocity. The dimension of velocity is LT to the power -1. In the same way, we can write down the dimensions of everything, other thing. For example, let's move on to the area. The area is equal to, let's say, length into breadth. Both of them are distances, so we write it that the dimension of area is equal to, in the bracket, dimension of length to dimension of length multiplied by length, or we call it as L square. Now we will not show that if there are m0, we also sometimes can write m to the power 0, l square t to the power 0, but if we don't write it, it's explicit. So in the so on, like the way we wrote it for velocity and the area, we can go on writing the dimensional formula for many other quantities, and I will go through real quick about it, about all of them, most of them. So let's go on to the momentum, for example. So momentum is defined as, if you have read into the law of conservation of momentum in class 9th and 10th, momentum is defined as mv. So the dimensional formula of m is m, and velocity is displacement upon time. So we can write the dimensional formula of ml t to the power of -1. The next thing you can come about the acceleration. The acceleration is defined as velocity divided by time, and velocity is defined as displacement divided by time. So we write it L by T, this is for velocity, and time is 1 upon T. So its dimensional formula will be equal to L T to the power of -2. So that is the acceleration. Let's keep on moving these things. Next would be that, let's say, density. We can represent density as mass divided by volume. So m is represented by L, volume can be represented by length into L length. So that will be equal to L cube, and this can represent it as m L to the power of -3. Next would be, like, say, force. Force is defined as mass into acceleration, and acceleration is defined as rate of the change of velocity to m, and acceleration is velocity is L to the power velocity divided by time, and this will become m L t to the power of -2. T into t square, it goes up, becomes m L t to the power of -2. In the same way, we could write the dimensional formula for pressure. Pressure is defined as force divided by area, and the force is given by m mass into acceleration. Acceleration is L t to the power -2, and area is L square. The dimensional formula for the force will be m L to the power -1 t to the power -2. Let's move on. Next thing would be the work done. Work is defined as the force multiplied by distance. So we write force multiplied by distance, and force has the dimensional formula mass into acceleration. Acceleration is L t to the power -2 multiplied by the distance is L. So it is m L square t to the power -2. Now from the force, the dimensional formula for the force, the work, which should be the same as the dimensional formula for the energy. So these two should have the same dimensional formula, because one thing can be converted into energy. For example, we know that mgh is the gravitational potential energy of Mars due to the acceleration due to gravity, and if you want to find the dimensional formula for this, then m is m, and then g is the acceleration due to the gravity, and that will be L t to the power -2, and h is the height from the, and then this will have the dimensional formula of L. So you see that m L square t to the power of -2 has the same formula, dimensional formula as the work. In the same way, we write kinetic energy as half mv square, and this will have the dimensional formula. The constants do not have a dimensional formula. This is fixed. So the mass m has the dimensional formula of m, and velocity has the dimensional formula of L t to the power -1, because distance divided by time, the whole thing is squared, it becomes m L square t to the power of -2. You note that the work or the kinetic energy or potential energy all have the same dimensional formula. The similar thing will all have the same dimensional formula. Moving on to some more things. Angular velocity is the next thing that comes to my mind. Angular velocity is defined as, so angular velocity, let's say this is angle theta, then the angle subtended in unit time is called angular velocity. Omega is called as d theta divided by dt. Now d theta, the theta here is a special thing. in terms of the definition of angle, is this, if this is an arc and this is radius r, then this angle theta is defined as x upon r, and x is distance, r is distance. So theta is a dimensionless quantity, and therefore I will write, instead of, because I am not introduced to the calculus, so I will write it as delta theta divided by delta t, rate of the change of the angle. If something is moving with an angle or rotating something, how fast it is rotating, angular velocity is a measure of that. And because the change in the angle itself is a dimensional quantity, so we will have the dimensions of 1 upon t, or t to the power of minus 1. This is the dimensions of angular velocity. Before we move on, I have one special comment about theta. Theta, you know, that is sometimes we measure it in the radian, we can measure it in degrees, and we measure it in other possible units. Theta has a unit, but it does not have a dimensional formula. It's one of the specific quantities, physical quantities, that has a unit but not the dimensional formula. Next, we could be to that, we have in the high school, we also may have read about the impulse. The impulse is usually a force applied for a small amount of time, that is defined as F into delta t, and it has a dimensional formula of force is mass into acceleration, to m L t to the power of minus 2 multiplied by t, and that will have a dimensional formula of m L t to the power of minus 1. And from this, we probably have read that impulse is equal to the momentum. And let's verify that the impulse dimensional formula of impulse is the same as the dimensional formula of the momentum. Momentum is defined as mv, so we have ml. M has a dimensional formula of m, and velocity is meter per second, distance divided by time, so lt to the power of minus 1. So these two dimensional formulas are same, so we know that the impulse and the momentum, they have the same dimensional formula. We will move on to the one way you can do is you can also take a break in the dimension, because we will come across a lot of new physical quantities that we will read during class 11th and class 12th. And if you are not aware, the chapter may look a little overwhelming, not because this topic is difficult, because they will introduce you new terms and new things that you may not have be aware of. And usually the problem should mention the physical quantities it's talking about. So one of those quantities is gravitational constants, because you will have the many problems here, so I want to mention it is, we will read it in about the gravitation chapter. The force, and this says that their force, there are two masses m1 and m2, they attract each other with a force that is given by g m1 m2 divided by r square, where r is the distance between these two masses, and we need to find out the dimensional formula of this constant g. So g we can write is the dimensional formula of F multiplied by r square divided by m1 m2, and force is mass into acceleration, so mass acceleration is meter per second square, or lt to the power minus 2, radius square is l square, m1 m2 is m into m goes away and m goes up, this becomes m to the power minus 1, l square, l and l square is l cube, t to the power of minus 2. So this is the dimensional formula for the gravitational constant. You can revisit it again when you read the gravitation chapter. Another such looking difficult one, we sometimes talk about the Planck's constant. And the next thing that comes to my mind is Planck's constant. And Planck's constant is given by the relationship E is equal to h mu. H is the Planck's constant, E is the energy, it's the energy of a photon. It depends upon the frequency of the photon. Photons are like a wave energy, and these wave energy, if they have higher frequency, they have higher energy. So the dimensional formula of H will be the dimensional formula of E divided by the frequency. And E is the energy, is given by the dimensional formula of energy is nothing but the work done, or force into distance divided by mu. Now force is mass into acceleration, m L t to the power minus 2, d is denoted in is D has the dimensional formula of L, and frequency is 1 upon time, so we can write it as 1 upon time, T goes up and then it becomes T, so its dimensional formula will be M L square and T minus 2 and multiplied by this T is T to the power minus 1. So that is Planck's constant. One of the questions that is often asked is Young's modulus, and I will go briefly about it because there are some questions Young's modulus about this, and I will briefly talk about what this quantity is. It was discovered by a scientist called Young, and then let's say this is a structural beam or something, and you are trying to some kind of put a pressure on it, and because of this pressure it tries to compress or it tries to elongate. So it's a measure of Young's modulus is a measure of the relative displacement compared to the force you are applying to it. So let's say if you are applying a force F upon an area A, then F upon A represents the stress that is being created to this mechanical structure, and because of that it moves by a, let's say, delta L length, and the relative strain it causes to this mechanical structure will be given by delta L by L, and Young's modulus is a measure of how much stress is caused with for a given strain, relative strain, and therefore the dimensional formula of Y, Young's modulus, will be the same. Now first the dimensional formula for the strain is nothing, it's 0, m to the power 0, L to the power 0, T to the power 0. Strain is a dimensionless quantity, but stress has the dimensional formula have same as the pressure, because it's the force divided by area is also the dimensional for the pressure, and force is mass into acceleration, Lt to the power minus 2 divided by L square cancel, so this has a dimensional formula of mL to the power minus 1 T to the power minus 2, and therefore Young's modulus will also have the same dimensional formula of the stress, or mL to the power minus 1 T to the power minus 2. So we talked about the Young's modulus. We talked about pretty much most of the things that your exams will ask. There is another thing we want to discuss is the surface tension. Sometimes it comes into your mind. So everything, if you have a surface of like a water, it is in a stress because that's what it keeps its shapes, and the surface tension is defined as force acting upon a unit area, and the dimensional formula will be the dimensional formula for force, m mass into acceleration, mLt to the power minus 2 divided by the dimensional formula of length is L, and this will be mt to the power of minus 2. So we talked about a lot of we can go on writing the more and more dimensional analysis, and you don't need to worry about it. All you have to do is, anytime the question comes up, try to know what is the formula for it, and then write down its dimensional analysis. There are two areas that are left. Is that I have earlier told that I already only talked about the mass, length and time, but there are two more quantities that we want to talk about, and one is the dimension for temperature, and this is denoted by K. If a physical quantity has a temperature into it, then that will be represented by the letter K. For example, let's talk about the Boltzmann's constant. It's represented by the equation PV is equal to KT, where K is the Boltzmann constant and T is the temperature. So the dimensional formula of this Boltzmann constant K will be PV divided by T. P is the pressure and V is the volume. The pressure is the force divided by area. Force is mLt to the power minus 2. Area is L square. V is the volume, so it's L cube. And now that here comes the new term T, and the dimensional formula of T is represented by K represents the Kelvin. So we have m L square, and as L power force is L square T to the power minus 2 multiplied by K to the power of minus 1. This is the dimensional formula of the Boltzmann. Anytime we will deal with the thermodynamic, anything that involves temperature will have the K as the new term for the dimensional analysis. Another term that comes to my mind is before we do that, the dimensional formula of the calorie or heat or calorie, which is measured in calorie, is the same as same as energy or force into distance. Now, if I ask you the specific heat, which you have studied in class 10, then this Q is equal to mc T2 minus T1. The Q is the energy and C is the specific heat. The specific heat is the amount of the energy or calories required to increase the unit mass of a substance by a unit degree. For example, water has a high specific heat of 1, anything else has a less specific heat. We are required to find the dimensional formula for C. So dimensional formula for C will be equal to Q divided by M into T2 minus T1, and Q is nothing but the energy. Energy is force into distance. The force is mem L T to the power minus 2 multiplied by distance L divided by M is mass, and T2 minus T1 is the temperature, and that we talked about is represented as Kelvin. And then this will have the dimension of M cancels, L square T to the power minus 2 and K to the power of minus 1. That's the specific heat. So anything dealing with the thermodynamics that has a temperature term will have the dimension of the K in its dimensional formula. The more moving on, we have few more things besides the temperature. We also have another term. If we are dealing in the electricity, we'll cover electricity and magnetism in second part of this whole thing. There is another thing we measure is I. Probably you have heard about the Ohm's law. That Ohm's law says that V is equal to IR. If there is a resistor and when we connect it to the battery of voltage V, a current I flows on this resistor, and that is given by this relationship V is equal to I. Now I has a fundamental, if there is any electricity flowing in it, then I is a basic unit, and in terms of which we can express the dimensional formula of other things. So let's first talk about the dimensional formula for Q, charge. Now we define I as the current flowing, the charge flowing in a unit period of time. So the dimensional formula, if you are asked, the dimensional formula of Q will be the dimensional formula of I into T. So the dimensional formula of I into T. So this is the dimensional formula of Q. So next we will try to find out the dimensional formula of the voltage V. And what is V? What is V defined as? The voltage. Voltage is defined as the work done in unit positive charge from bringing infinity to some point, that is W by Q. W is work done is force into distance divided by Q. Q is nothing but charge into time. So this is dimensional formula of I into T, and force is mass into acceleration, Lt to the power of minus 2 multiplied by the distance D is L, and divided by I into T. T goes up, this becomes M and L T to the power of, this is I, M L T to the power minus 3 into I to the power of minus 3. So this is the dimensional formula of voltage. We find the voltage, we find the, in the same way we could be asked, let me check if this is correct or not, because that's based upon this we will check other things. F into D, force is MLT to the power minus 2, distance is L, I into Q is IT, I into T, so MLT to the power minus 3 into I to the power of minus 1. Now the next thing we could be asked about the dimensional formula of R. R is equal to V by I. So V we can represent as this things, MLT to the power minus 3 into I to the power minus 1, and I here again, so I goes up, so it becomes M L T to the power minus 3, I to the power of minus 2. If I am making a mistake in anywhere, you can just check it back. It's not necessary that I do it everything 100% correct. You just need to know the steps that is required to find the dimensional formula for the various quantities. These are the things that we need to cover in this lecture, And then the next one would be we will do this one first in this lecture. If it's getting too long, conversion of units. That's the one of the advantages of using the dimensional analysis. Let me check if my video is continuing, because there is a lack of storage. It may stop any time, but it's continuing, so I don't know how much memory I have in the video being recorded. So the conversion of unit is one of the applications of the dimensional analysis. And let's say we are given 100 watts of power, and we are required to convert, and this is obviously MKS unit or SI unit, and we are required to convert this unit into, let's say, CGS unit. So you don't need to memorize or remember the conversion ratios for everything. All you need to know is that mass to kilogram to gram and kg to kilometer, meter to centimeter conversion. So let's go about this. This power is a watt. Watt is nothing but, power is nothing but work done in a unit period of time, and work is force into distance divided by time, and this becomes, force is mass into acceleration, lt to the power minus 2, distance is L divided by t. So this becomes mass into L square multiplied by t to the power of minus 3. Now what we have is 100 watts of power. So we write 100 here, and now this one is in MKS. That means this mass is measured in kilograms. So we write 100 kilograms. 100 kilograms, we convert it into CGS units like grams. So we write 10 to the power 3 to convert this mass kilogram into grams. The length, MKS unit is meter, but CGS likes the centimeter. So we write 10 to the power 2. 1 meter is 100 centimeter to the power of 2. So if we convert this thing, whole thing, we get 10 to the power 2 into 2 is 10 to the power 4 plus 3, 7 plus 2, 9. So we have 10 to the power of 9 in CGS unit. Whatever it is called, I don't bother, I don't remember, but this is the step you use to convert one unit from MKS to CGS or something like that. I will give one more example of conversion of units, and then we will probably stop this here. We have another lecture which is very important. Make sure you go to those things also, because these are the real good applications of the dimensional analysis. So let's say we measured the pressure, atmospheric pressure, and its typical value is 1.0 into 10 to the power of 5 Newton per meter square, and this is in MKS unit. We are required to find it out in CGS unit. So let's say, how do we measure the pressure? Pressure is force divided by force acting upon in area, and force is mass into acceleration, lt to the power of minus 2 divided by area is measured in length square or L square. This becomes ml to the power of minus 1. 2 goes up, becomes minus 2 multiplied by 1 is 10 to the power of minus 1 multiplied by t to the power minus 2. Now we are given as 1.0 into 10 to the power of 5 multiplied by mass in MKS unit is, mass is measured in kg, but CGS does not like kg. CGS say I like only gram, so I say okay, no problem. I converted you into grams. 1 kg, I have converted it into gram by multiplying you by 10 to the power 3. Now L goes down, and then when L is here, L is in meter here in MKS. CGS say hey meter, let me convert it into centimeter, so I multiply it by 100. So 10 to the power 3 goes here by 100 multiplied by 10. So whatever value of this here, it gets multiplied by 10. It is 1.0 into 10 to the power of 6, and whatever units of CGS here, I don't remember now, but you need to, in case if it's required. So any pressure, if you need to convert from MKS to CGS, just multiply it by 10, and that is very easy because of the dimensional analysis, because all we need to know is what units are. Meter and kg is converted into CGS. Homogeneity principle and check equations, find equations, these are the topics we will cover into the part 2 of this lecture, and we will also then do, maybe in the same one or another one, We will cover the NEET questions, entrance exams questions, and IIT questions in another lecture, so you know what the real life problems look like in engineering and entrance examination. Make sure you check out subscribe this channel if you want to keep getting more lectures about it. I have also solved all the problems of H.C. Verma in this channel itself. So go through each and every problem of H.C. Verma, and if you have any problem, just search for it with our channel name into it and look the solution that I have provided with this lecture and make sure you understand it completely. If you do not understand, just maybe ask me in the comment section and I will try to make another video to clarify anything. I may have made mistake in some of these steps. I'm not sure I'm 100% correct, but I think I'm following it logically. If there are errors, there may be logical errors. You can point that out and I will post my comments. And that's, I think, is all for today. Do all the problems and look for the next lecture and do more problems and so on and so forth. Thanks for taking a look.